Hi there, my name is Mark Schneider from Grinnell College, and this is the first of several videos in which I'm going to show you different ways of trying to find a spring constant from actual measurements. First, we're going to measure this directly, and the, the spring is a familiar thing. We're going to look at a spring hanging vertically and measure first exactly how you get that spring constant from a direct measurement. We're going to make that measurement now, as you see with this green spring gauge here, that will actually, we're simply hanging it from the spring and we're going to measure the force that we get on this. The force that a spring gets is proportional to displacement, but it raises the question of displacement from where. So we're going to bypass that by putting in a zero position, which we're calling x naught in here. This means that we need to make two measurements. The first measurement will be a little bit of an extension of the spring, and here we see the spring gauge, and you see that it's displaced about 14 and a smidge more. We're going to call that about 14.3. Then we're going to make a second measurement, and here we'll see on the spring gauge that now it's been stretched a little bit further to 20 and a little bit, almost 21. Now if you take those two expressions for the forces and you subtract one from the other, you'll see that that x naught in there is going to disappear on us, which is just great. Then we don't have to worry about that at all, and we'll see that the forces, the difference in forces is going to be proportional to the difference in the two positions. The force is directed upward, which we conventionally call a positive direction. So we're going to write those as positive numbers. And the positions, because those are pulled downward, those are going to be negative numbers. So we'll plug in those two values that we measured from this, and we're going to see what we get out of it. The difference between the two forces is simply 1 Newton. The difference between those two positions is 0.066 meters. Rearranging this, I find that the spring constant is simply equal to 1 Newton divided by the 0.066 meters, or about 15 newtons per meter. This is a little bit of a coarse measurement on here because the spring gauge is not terribly accurate, and our ability to look at it exactly along the side there was not the best. So we're going to guess that this will agree only roughly with some of our other measures.